Hello community, so great that you are here. Today we talk about the new tool Sync by Claude 3.7 Sonnet. And you might think, this is a new Sync tool. This sounds interesting. Yes, let's start. Well, it is not really related to what we had a month ago, where Claude had this announcement of an extended syncing. But it is somehow related. Let me explain. Now, in this video, I showed you here the Sonnet 3.7 syncing with 32K and 64K. And this is what's called extended syncing here. But you know exactly what it is. No, we have the training time, we have the pre-training, the supervised fine-tuning, the reinforcement learning, our DPOs, and then we have the inference time. Here comes now the user query. And we have this, what it's called test time compute scaling, TTS. This is also our reasoning models, our R1 by DeepSeek, our O1 by OpenAI, our S1 by Stanford University, or also called the long chain of thought models, or like here, Anthropic calls it, the extended thinking models. Simply means we have to wait, 2 minutes, 20 minutes, because given here my specific query, the AI is now really doing here some thinking. Now, how does this new tool of thinking fits into this? Here we are. So you see, we are within the test time compute scaling regime, but we can invoke it here, for example, here, or maybe we invoke it here. And what it is important, it is a tool in itself, and it is in relation to other external tools. So now that we have an idea where this thing is living, let's have a deep dive. Let's open up this video and let's see what it is. Now here I have some statement here by Sonnet 3.7. They say this new tool that really improves here Sonnet's complex problem-solving performance. Whenever something improves the performance, I am interested in this. So it is a sync tool that creates a dedicated space for structured thinking. Now, this is an interesting word, no? Because a tool that creates a mathematical space, is it a vector space, a tensor space? What kind of space is it? What kind of space connects are we talking for? For structured thinking means JSON, or what are you talking? Template structured? So I really got interested in this. And then remarkable improvements here in Claude's agentic tool use ability. And here we have another hint. It is about all the tool use, another agentic tool use. And this includes following here particular policies. We're going to talk about this in a minute. Making consistent decisions and handling a multi-step reasoning problem. So great. But you see, we have a focus here on tool use and extended thinking. So what we need is a spark of genius that we say, hey, this is easy to understand. Let's have a look. We follow here the instruction, and Anthropic tells us with the sync tool, we are giving Claude the ability to include an additional syncing step. This is interesting, no? Because I thought here the whole syncing process here with test time compute is syncing on 100 or 1000 GPUs. So we add now an additional syncing step. Beautiful. Designed with its own designated space. It even gets more interesting. And they say here, the sync tool is for Claude, once it starts generating a response, to add a step to stop and think about whether it has all the information it needs to move forward. And here they tell us it's particularly helpful with performing long chains of tool calls. And I say, okay, so we get a lot of tool calls back. And now all this, parallel input from 7 different tools, the tool calls return the result. And now we need somehow to have here a stop command for the complete LLM and say, I give you now a space, I create a space for you with a structured knowledge so you can analyze this and improve the performance. Interesting. So, extended thinking in the definition here of Anthropic is, when they define this now, the use case, it is for coding, math, and physics. And I think, okay, yeah. And then they continue when you don't need Claude to call tools. Now, I do not agree with this because in physics, I call different libraries. I call here C++ environment for having here a virtual experiment in C++ coded. I want the results from my virtual supercomputer returned to my AI system. So I do have a lot of tool calls in my physics department. So, okay, but they try to make it clear here. Okay. And then this new tool here is better suited here when Claude needs to call complex tools. Analyze tool outputs in long chain of tool calls again. So multiple tool calls return the result. Navigate here policy-heavy environments with detailed guidelines. And at this point I said, okay, it is not about just returning something, but we have to follow here particular policy guidelines. Because I've seen on the internet, some said, hey, it's just a Scratchpad, no? That's it. No, this is not the case. So something is missing here in my understanding. So I went to the paper and I thought, oh yeah, I got it. Because you have to read this paper from Sierra Research. Otherwise, you don't have any easy access to this topic. But with this was published here June 17, 2024, Sierra Research, Tau Bench. So it's a benchmark for tool, agent, user, Tau, interaction. And they tell us, and this is not so long ago, show that even state-of-the-art function calling agents succeed on less than 50% of the task. So they tell us, hey, you know, the function calling agents, they are not really successful that you would say like hard-coded. We have a SQL and we get a return back from the database and we have a result from the database. This might not be the case if we use AI agents, you know, with function calling. But you remember, this function calling is just a bridge that we built for the artificial intelligence to the database. But what happens on the bridge, what commands are passed over the bridge, this is up to the artificial intelligence. This is not hard-coded by us. So if you have a look at Sierra Research here, GitHub Tau Bench, really nice. Have a look at this. They explain this in detail. They have a leaderboard, real nice. And just want to give you here the result. No? They say our agents here in Tau Bench often fail because they struggle here with particular reasons when they're interacting here. And they have here an API, they have here function calling, a tool use database. But whatever your tool is, just substitute here your specific tool. And they say we have three main reasons. So A, complex reasoning over structured data. The agent sometimes filled in the wrong arguments or omitted necessary details in their tool calls. Which is not really what you want if you wanted the system just here publishes here a function tool call, text to SQL, and it's not working because it's missing or has an incorrect term, an incorrect ID, not accounting for all required fields. This all leads to failures. Great. B, the Tau benchmark told us here that agent frequently made incorrect decisions and didn't follow the provided rules. This is not so good because rules are there for a particular reason, how to handle this system. And if the rules and the condition on the system were not reliably enforced by the agent, we run into problems. No? So, shows that the agents were not integrating the domain policies into their decision-making process. If the agent doesn't know how to handle this agent, that's not good. And then we have handling compound requests. And they said when task required multiple steps, agents sometimes only partially completed the task. So the agent said, okay, I'm 50% done, that's it, it's a Tuesday, come on, let's go and have a celebration. No, of course not, I'm just joking, but in the training data of this particular agent, there was a particular probability distribution, and calculating now the next step, the next token here, it was not an action token, but it was a termination token in the distribution here of the test data, and therefore the agent decided, I can now stop. So if you stop here, this is not great, and you have an overall failure. So this paper here, this research paper of Tau Bench was essential because also the example given were exactly the examples that later Anthropic showed us here for Claude Sonnet 3.7, if you want, tools. And you know what? Already a year ago, the authors here of Tau Bench told us, we have also experimented with adding a sync function for those function calling agent, but it did not boost the performance. And I was absolutely fascinating reading this 1-year-old sentence, because this is exactly what Anthropic did now to Sonnet 3.7. No? It added a sync tool for their function calling agents. But why at this time it had no effect, and why now a year later it has a more than 50% performance increase? Yes, it gets even better. It's really interesting. So let's have a look at the core idea. The tau benchmark is the main thing that we have to understand here the, if you want, sync tool. So we have this setup here on the left side. What we have a user. This user is, of course, simulated by an intelligent large language model, let's say an agent. And then we have here, let's do this here. This is here a flight booking exercise. So you want to book a flight from New York to Los Angeles on a particular date. And we have now an agent here from, I don't know, Delta Airlines or Alaska Airlines or Spirit Airlines, whatever you like. Please insert your line. And this agent now has a particular policy to implement. And this agent has in its system prompt now all the rules and the regulation of Spirit Airlines. And for example, the booking agent there says, hey, the basic economic fare cannot be modified, but the basic economic cannot be cancelled after 24 hours of bookings. And there are, I don't know, 25 different additional rules. So this is what they call here the domain policy constraint for the agent. And of course, if the user now interacts with the booking agent of Spirit Airlines, this domain policy has to be here one-to-one implemented. Not okay if you do here a mistake. And the agent, of course, has API calls, has function calling, has tool use abilities. Let's say it has a tool to a flight information database, and to the booking database, and to the payment database, or whatever. You get the idea. So you have different functionalities. Get user detail, book the reservation, up to the reservation flight. Everything is defined here. So this is now our setup. And now we have here this human and says, hey, I want to change my flight. Instead of flying to San Francisco, I want to fly to LA on the same date. So what is happening now? The example trajectory now in this tau airline example, that will become important later for us, is simple. No, the human says, hey, I want to change my flight. This is my detail, whatever. The bot says now, okay, I have to go to my internal flight database, have the reservation database, get the reservation detail for this particular person ID. It reads the database, gets now all the booked details, beautiful. Bot comes back and says, hey, Mr., Mrs., whatever, you booked basic economy, this cannot be changed, but since it is within a 24-hour window, I can cancel it and book a new one. Do you want me to do this? Then we have here a multi-turn dialog. Maybe the bot canceled this, writes here a new order in the database. So this is the scenario we are looking at. And they found there are real problems here, given now Sonnet 3.7, to perform this task. In the paper here for tau benchmark, they give us here a beautiful example for every single step if we have a successful booking. So let's have a look at this together, that you just see all the interactions between the agent and the database, and between the agent and the user, and how everything is communicated. So instruction is, from a human user, I want to fly from New York to Seattle on a particular date. I don't want to fly before 11 a.m. I want to fly in economy and whatever. So here we have another conversation. And the user says, hello, I'm planning a trip and need to book a flight from New York to Seattle. And the assistant says, sure, can I help you? What is your ID? The user says, my user ID is, okay. And the assistant says, great, thank you. So I need now some further details, a one-way or a round trip. When is your departure date? What class will you like to travel? The number of passengers? Do you want to purchase a travel insurance? Great. And the user just answers here everything. And then the assistant decides, okay, great. So I have now the ID of the ID of this particular person, and now activate the function get user details. What are the details of the user in my, let's say, financial database? So tool comes back and gives us here all the results with the name, first name, last name, the address, email, the payment method, the credit card certification, the credit card source, the brand, Visa, the passenger, whatever. Beautiful. And then the assistant says, okay, now I define a function. I have an origin and a destination I want to fly to on a particular date. So I have now the command search for direct flights between those particular origin and destination points. And the tool comes back and says, hey, I have this flight number and all the data, beautiful. And then the assistant comes back and says now to the human, hey, those are 2 available flights, departure, arrival, available seats, the price, or another flight, departure, arrival, and the price. Please confirm which flight you would like to book. Now the user says, they are a little bit too early for me. Is it possible to fly after 11 a.m.? Assistant says now, okay, let's define a new function. We have now search for a one-stop flight from JFK to Seattle on this particular date, and gets back here from, I don't know, any flight information database. Those are the available flights with all the available information. Now imagine there would be just one hallucination here, but no, nothing happened. We are in the perfect case. System comes back. Yes, I found here multiple options for you. So flight option 1, the first leg would be this, the second leg would be this, flight option 2, and you get the idea. So system says, please confirm which flight you would like to book. And the user says, I go with the first option. Beautiful. Then the assistant tells here, verification, here are the details of your booking. Yes, yes, yes. Here are your payment methods that I have in my system. Please confirm you would like to do this. User says, yes, booking information is correct, but for the payment, I would like to use my 2 certificates first. And the assistant says, hey, for safety reason, only 1 travel certificate can be used per reservation. So you see, now the assistant is aware that there are certain policies it has to implement, so it's not possible to follow the instruction by the user or the wish by the customer, but it says, hey, sorry, I cannot accept this. There's only 1 travel certificate can be used per reservation. The payment details are this. Confirm if you would like to proceed. And the user says, yes, I confirm. Please proceed with the payment arrangement. And the assistant has now beautiful book reservation. So we have now a function with all the available information with your particular date, with the particular flight, with the particular payment method, with the particular whatever. Great. And then we have the tool. Yes, beautiful. More or less, this is now what has been booked. System comes back to the human, says, your flight has been successfully booked. Here are the details of your reservation. Again, for the humans. Finished. So this would be really in a beautiful, transparent way that you see each function calling, each tool response here. This would be the perfect way. And now you imagine that somehow the AI system decides not to fill in the correct information, but maybe to mix up some input fields, or maybe not provide all the required information. Maybe at a particular timing point, the system starts to hallucinate. Maybe the system calculates here that a probability to continue here not with an action token, but with a delete token. Suddenly we are going in loops. So there's so many things that could go wrong, but I just wanted to show you this would be the perfect process. So now let's continue. So coming back now, here we have now a look at the facts at the announcement here by Anthropic. The sync tool enabling Claude to stop and sync in complex tool use situation, published just 4 days ago, March 20, 2025. So I have seen it only on Sonnet 3.7, but if they say Claude in general, maybe it works also for other Claude models. Great. I just want to show you now the implementation using the standard tool specification format JSON. This is it. This is the sync tool. Name, sync, description. Use the tool to think about something. It will not obtain new information or change the database, but just append the sort to the log. Use it when complex reasoning on some cache memory is needed. So now we understand, hey, this is more or less just an additional memory that will append here additional information to our log. So whenever a new tool result comes back, it will be appended to our log structure. Because our input schema tells us, hey, we have an object with the property sort, and it is simply a string. This is it. So it is a Scratchpad. And you say, but how is it possible that a Scratchpad can have a 50% performance improvement on Sonnet 3.7 doing this flight reservation, for example? Well, there is now the detail that is important. Have a look at this. This is here from the official Sonnet, Claude 3.7 Sonnet performance paper here, this airline task, no? Rebook a flight. So we have here in blue the baseline performance here. And you say, okay, that's the baseline. And then we have the pure thinking tool performance in yellow. And you see, this is almost here a little bit better than baseline. But look, here it is baseline. So the improvement is marginal, almost nothing. And then we have the extended thinking that was published a month ago. You remember test time compute scaling? 2 minutes, it's really thinking and thinking about this. This is here our orange line. And then we have here the performance line. Look, so much better performance. But what is it? This is think tool plus a prompt optimization. So now I understood. Okay, so just giving this system a Scratchpad with a think tool, the performance is going to be almost zero compared to baseline, because what is the operation? Eh? But if you think, I add now a think tool and a prompt optimization, and I give here in the prompt optimization here a particular memory allocation to do here verification or falsification, then the think tool makes sense, because it just opens up a space, a mathematical space, not even a vector space. Just you store some strings. Let's have a detailed look. So they tell us, the best performance of the airline domain example was achieved pairing here the think tool, our Scratchpad here, with an optimized prompt. And this optimized prompt gives you an example of the type of reasoning approach to use. And you say, wait a minute. The optimized prompt gives examples of the type of the reasoning that we want the system to apply when analyzing here customer request. But this is a policy template, no? This is a structured, ordered flow of procedures. These are a few short examples in our in-context learning directly on a prompt. This is something that we know of, no? So let's have now a look at this think tool and now at the optimized prompt in an example, 2 examples. The think tool does what? Use the think tool as a Scratchpad, as a new space, as a new memory you can feed some information to. But now it is not just some information, it is a very dedicated sequence. So they tell us here, list the specific rules, the policy guidelines for rebooking your flight, in our example here of an airline, that apply to the current request. Then check if all required information is collected. Template, check, 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 check. Verify that the planned action complies with all the policy that are now defined in the system prompt, and then iterate over tool results for the correctness. So you see, it is not just a Scratchpad. It is so much more, because what we have is the optimized prompt that really provides now the added value, the added performance jump. Let's have a look at this. What is the optimized prompt here? Start think tool example 1 and think tool example 1. User wants to cancel the flight ABC. So we need to verify the user ID, the reservation ID, and maybe there are only some valid reason that you are allowed to cancel a flight. So is this the case? So the system now goes in its particular memory and says, check the cancellation rules, check the policy that we have as Spirit Airlines. Is it within 24 hours of booking? If not, check the ticket class and the insurance. Verify no segments flown or are in the past. And then plan, collect the missing information, verify again the rules, and get a confirmation from the user. So in my simple implementation, this is not a tool use, but this is just that you have here a verification template or an instruction following for a particular case. The case is user wants to cancel the flight, what the system has to perform. Second example. little bit longer, no? The user wants to book 3 tickets to New York City with 2 checked bags each. So again, we just have here in this optimized prompt that really brings here the performance jump to Sonnet 3.7. User need the user ID, the baggage calculation. If you're in economy class, 3 passenger, you have 1 regular member, 1 silver member, 1 gold member, whatever. You have the complete policy implementation, how to calculate this, payment rules to verify, and then the plan how to proceed here in a clear, maybe linear sequence. So you see, this is it. This is so much similar to our old-fashioned ICL prompts, from 2 years ago. So whatever Anthropic implemented now is an old friend. It is, if you want, from the mathematical space, added memory, but in this memory we have now clear instruction to follow the policy guidelines and check if it's valid and. So it is the combination of the sync tool and the optimized prompting, implementing here the policy guidelines of our airline example, that we can solve now higher complexity tasks. And now let's turn this around. Because if Sonnet says, hey, now we can do this, does it mean Sonnet 3.7 would have failed to reason or perform this booking task or cancel your flight without the syncing tool and the domain-specific optimized prompt that includes now the policy guidelines of this company? So this makes me a little bit wonder, where is Sonnet now compared here in their agent performance to the other models here on the market? Okay, I think this is it for today. So what? Short summary. Sonnet 3.7 improved just by having here an additional separate space to think with further guidance. And I think now I absolutely understand what it means. We have just a little bit of memory. We have here specific template for specific user task, for specific companies, for a specific rebook or cancel a flight, whatever. So great, I understand it. And now Anthropic gives us here instruction when to use this sync tool that is just a Scratchpad. When Claude needs to carefully process the output of previous tool calls before acting and might need to backtrack in its approach, we have a log file. Great. Policy-heavy environments, when Claude needs to follow detailed guidelines and verify the compliance with the log file and with the template instruction. When each action builds on the previous ones, so credit card is validated, now we go on to have to book now a specific flight. Great. So these are the use cases where Anthropic tells us use the sync tool that we have now. And here, our research tells us the Anthropic has demonstrated that a sync tool can significantly enhance Claude 3.7 Sonnet performance on complex tasks requiring policy adherence and reasoning in long chain of tool calls. So I honestly thought that this is already implemented in Sonnet 3.7. Sonnet is a new model. I thought it is already optimized to have those tool calls and even chains of tool calls. But visibly, now with the new publication of this sync tool and the new optimized prompt in combination, okay, so we have to use those together. Beautiful. Optimized prompt gives you the agent all the necessary rules, and the sync tool helps you the agent to check its work against the provided rules. So for me now, in my understanding, the pure sync tool is just, if you want, a Scratchpad, where you have to check 10 boxes, and those 10 boxes are the policy implementation here of the airline for booking a flight online. Great. Now I think I understand what it's all about. Interesting, if you think a little bit deeper, it is about rule following. But rule following in the era of artificial intelligence is not really what we want, no? We want to have an artificial intelligence that has an inherent understanding what is the right path to go, what is the right implementation for a specific process of booking or canceling a flight. So for agents to truly benefit from it, they might need further training or some architectural modification to encourage you the use of such intermediate reflective processes that would allow to have this implemented inherently in the AI agent so that I don't need an external tool with rule-following rules implemented. This brings me now to my question, and maybe you have some feedback here. How far advanced is Claude 3.7 Sonnet compared to other models? Is it inherently self-reflective in its reasoning? Does 3.7 Sonnet has been trained on an internal self-validation in its training dataset? And has 3.7 Sonnet an internal self-correction ability? Because if it would have those things, we don't need, or it would not be so significant the jump in the performance if we apply a sync tool with rule following and a policy implementation. So this brings me to the overall question. I just noticed that Claude just published 4 days ago that Claude can now search the web. And I have to tell you, I'm not a specialist in Claude or Anthropic, but I thought that this is a functionality in our AI systems that are widely implemented. And now seeing that Claude just achieved this particular functionality just 4 days ago. So if you know more about this, if you have really experienced this for weeks and months here, what is this function calling specificity here? Does it have self-reflection? How good is it in self-validation? Do you have some experience? How good is Claude here, especially Sonnet 3.7 here, regarding this self-validation respect? If you're interested, why not subscribe, leave a comment, and I see you in my next video.